what we do first is we do a little bit of a introduction of yourself and your company and what you guys do, and then we can get into the actual content. So maybe Akshay, you want to start and just do a quick introduction? Yeah.
Yeah, absolutely. Thanks so much for the invitation. I'll hold it closer. Like was introduced, my name is Akshay. I'm one of the co-founders of Cognita, which is now acquired by Mosaic Clinical Technologies. But besides that, I'm also a professor of radiology at Stanford, where a lot of the work that I do really focuses on building large-scale vision language models for radiology and really trying to understand what are some of the best methods that we can use to train these next-generation models, and then how do we really pair that with how do we make sure that the models that we're building are actually serving value to end users? And that's really been the focus of the last year or so. How do we take promising technologies and then help cross the chasm that exists in actually making radiologists successful with them? What are the challenges from a model development side? What are challenges from an integration side? And make radiologists happy with these tools. So quick little intro, I'll pass it on to Jason.
Thank you. I'm Jason Klotzer. I'm a customer engineer within Google Cloud. I really focus on the innovation across Google Cloud for medical imaging related workloads. What that means is using the scale of cloud and the scale of Google itself to be able to really improve the medical imaging sort of landscape out there. Now, clearly, as AI has become this really, really impactful thing within the space, I'm obviously very excited, and that's what I'm trying to help with.
Great. Robert?
Yeah, Robert Bakos. I am co-founder and CTO at HOPPR. My background was primarily in software engineering. At HOPPR, I oversee our ML research, our software development, of course, our IT operations, all of the fun tech things at HOPPR. And as these folks have mentioned, we're focused on developing foundation models, being able to fine-tune those foundation models, being able to evaluate those foundation models with clinicians, with end users who are using them for workflow, operational improvements, those types of things. So HOPPR really has a platform that allows you to fine-tune those models and customize them for your particular use case.
Thanks, Robert. So why don't we just get right into it, and I'm just going to call you guys out so you don't even know what's coming, okay? Yeah. So Akshay, what the heck is a foundation model?
I have been trying to search for that answer for a long time. Everything is a foundation model and nothing is a foundation model these days. That actually led us to write a paper in radiology just trying to describe some of the terminology behind foundation models, and something that we ended up settling with is a foundation model is a large-scale model that's ostensibly trained in a self-supervised manner, so you don't necessarily need manually curated supervised data. And once you do this at a large enough scale, then this singular monolithic model can allow for a range of diverse tasks being solved, either in a zero-shot manner, which means that there's no adaptation that's needed, just a model that you've trained in a self-supervised manner works, or you can adapt it in a few-shot manner. So that just needs a handful of supervised training examples, so that if you want to solve a very specific task, you now have that capability. But I think that we just keep hearing this term foundation models quite a bit. I think to some extent, it's a term that's overused, according to me, because foundation models are, by definition, are not task specific. You cannot have a foundation model that is just doing classification on one particular modality. It needs to have emergent capabilities across a variety of different tasks. So I think these days, I actually prefer not using the term because it has such a varied definition based on who the user is. And I just like thinking about models in terms of what is the problem that a model is solving and how do we evaluate that it's working.
Thanks, Akshay. I like that definition. Jason, do you agree or disagree, or do you want to add to it?
I'm not going to disagree with the professor, but naturally, as you know, sales have a very big thing. I think as terminology comes out, as we see with agentic as well, it's probably going to stick, irrespective of the technical definition. So, yeah.
So, Robert, maybe a question to you, right? And this is also why I struggle with foundation models, right? Because everybody talks about, they have foundation model. I have one, you have one, everybody has one, right? Is it a foundation model if the end customer can't actually improve on it, right? So, do you really have a foundation model commercially available if you actually can't fine tune it? And I think that's what you guys are doing. So can you talk a little bit about that strategy, right?
Definitely, yeah. In my opinion, a foundation model must be adaptable. And so if you have built a model that is not adaptable, it may have been based on a foundation model, but the model itself is not a foundation model. I think that the definition really is that it can be fine-tuned to meet the end user's goals. And so at HOPPR, we are doing work like that, where we are fine-tuning that model for a variety of tasks. It may be classification, it may be report, draft generation, but ultimately we have these flexible models that have been pre-trained on a large corpus of data that the whole goal is to be able to rapidly fine-tune those with very few studies from there. So, we found things like our chest X-ray model can be fine-tuned for chest CT, for example, and then fine-tuned further with maybe just 100 studies to be really good at particular tasks for specific customer demographics. And so, that flexibility, I think, is really something that defines a foundation model from my perspective.
Great, thanks, Robert. Maybe a question to you, Jason, since I'm picking an Akshay to go first. Google recently made public one of their foundation models, right? The latest version of MedGemma. And can you talk a little bit about your strategy there, right? Why make this public? What's the bigger hyperscaler strategy with these models? How do you see that space? Yeah.
Speaking for all of them.
Yeah, just speak for all of them all at once.
Let me just go ahead and do that. So specific to our case, being able to make it public and being able to make the weights open weight, so as in anybody can take it and do what they want with it. We've found that because of the rate at which people are developing these models, adapting the models, being able to use them, fine-tune them in most cases for specific use cases, really putting it in a way where it is not public, it doesn't do it justice. And I don't want to necessarily mention any commercial constraints around it or things like that, but the rate itself just doesn't meaningfully really require you to do it, which we thought, and we saw that as a result with MedGemma. So some of our first models, we kind of we sort of drip fed them out publicly from a foundation model standpoint, and the adoption was okay. It was okay. So chest X-ray, CT, things like that. But then when we opened them, the adoption and just getting feedback from groups that were using them, mainly academic or some in the commercial space, it was just phenomenal, and it really gave us a better vector in which we were kind of deciding where to go, which is also why MedGemma, when it came out, and we're going to subsequently be releasing MedGemma 1.5 very quickly, we saw an exponential growth in the use of that model, which was just phenomenal to see. So yeah, open weights for us, we definitely saw major market interest in that. So I'd say, just in summary, it's mainly around how quickly the models evolve, which was the primary reason.
So maybe let's transition a little bit to use cases of these models, right? I think we've seen a lot of foundation models in the more basic routine imaging, right? There's several of them in the X-ray space. You start seeing them now also in some of the CT areas. Robert, maybe a question to you. Where do you think the first real-world applications will be in this space? Maybe talk about some of the use cases that you're working on, or maybe some of your partners are working on, that you can, kind of educate us on?
Sure, yeah. A lot of our partners are focused on kind of workflow-oriented scenarios, being able to, route different studies to potentially different groups of radiologists based on, certain classification tasks that are performed. Really just being able to kind of optimize workflow so that they can, leverage the right radiologist for the right goal. We've also been looking at obviously report generation, which I think has a number of really exciting implications in being able to improve radiologist workflow, speed up their workflow, get a report pre-drafted into their tool, and allow the radiologist to just be able to kind of modify that report to fit their needs, and hopefully, that's minimal effort as the models kind of evolve and get better and better. So I think that those are some really kind of innovative, exciting opportunities where we're seeing a lot of traction.
Thanks, Robert. Maybe it's the same question to you, actually, since you're kind of also very close to the end user as well.
Yeah, I think one of the use cases that we've been focusing on is really this notion of report generation. How can you really go from an image to coming up with a preliminary draft of a report that a radiologist can actually use in conjunction with their routine read? I don't have to explain to this audience that volumes are rising exponentially, reimbursements are going down. So I think this is a real pain point that radiologists are facing. And that's why we've really been developing models, not a foundation model, I don't really like that term, that solve that particular task. And I think there's a lot of effort that is needed to be able to train these next generation models. I think what we typically think of in creating these foundation models just really relates to pre-training of models. So can we build some self-supervised approaches to learn a useful enough representation of the data? But we are ignoring post-training. There is a reason engineers hired at Meta are paid $50 million. It is because they are the world experts in post-training. And that is where all the capabilities really emerge from these given models. And unless we focus on models that have optimal pre-training and optimal post-training, only then will we be actually able to hit the long tail of use cases that radiologists face. Because at the end of the day, radiologists don't want a model that works 85% of the time, 90% of the time. They want something that works 97, 98% of the time. And without optimal post-training, I don't think we will get there. And post-training is a really, really challenging skill to hire for in this market. And I think that is what makes fine-tuning of models really challenging for an average end user, because there's just not that sophistication to be able to understand what are the best reinforcement learning approaches we want to use, how does it relate to the data. So I think that's really the opportunity that we're trying to solve by being able to hire the people who go work at DeepMind, at Meta, at Apple, and really have them be super mission driven and solve this singular task, going from an image to the text, understanding findings, the size, the chronicity, taking into account prior imaging. And I think we're seeing some really promising preliminary data. Happy to share that later too.
Yeah, and maybe just as a follow-up to that, I think the notion of post-training also opens up, and I think it's a good transition to the elephant in the room, which is the regulatory context, right, for this. And maybe a question to you, Jason, maybe we can pick it up, and then maybe also to you, since you guys are working in that space. How do you see the regulatory landscape, right? And it, not just on post-training, but also really getting the first of these models, because the FDA isn't used to seeing models in this context. And this is to everybody, so maybe you start.
It's a hard question. I know, I love it. I love this question, actually.
You're going to all get this question because I think it is the elephant in the room.
So I fully agree. Yeah, it's very interesting just seeing the evolution of FDA when it comes to AI in general. So, we started out with, sort of these classification models everywhere, and, the FDA kind of came to a point of understanding of what they put people through from a process standpoint, to get the 510K, et cetera. Now we have generative, we have, I'm not foundational, right? or foundation models. I think it's very hard to understand the technicalities of the model architectures that are being used right now, which clearly the FDA comes from an environment which is pretty deterministic in a way where you need to prove exactly what the results will be, all the time. I think they will get there. I can't tell you when or how, but we are starting to see some models at least get some preliminary clearance from a generative even sense or a foundation sense. So I think they'll get there. When, I don't know, but that's the FDA,
Robert?
Yeah, I think generally the stance we've kind of taken is that the foundation model itself doesn't really need to go through regulatory. It's when it's fine-tuned and has an intended use that regulatory use case becomes a concern. From our perspective, we're really trying to build a component of a medical device rather than the medical device itself, and so we offer up our solution through an API, and then co-developing with our customers can help facilitate kind of that regulatory process. But I think because it is something that's a moving target, it's something that we're all kind of watching, and especially when it comes to that generative AI, generating draft reports, we know that that's going to be, a really interesting space that the FDA is kind of looking at. So I don't know that we necessarily have the answers on where it's going from that perspective, but I think that it's certainly something the FDA is going to have to contend with really soon here. And I know folks like Akshay are actively kind of pursuing this with the FDA. That I think it's going to be really exciting to see where folks are taking it.
And Akshay, maybe you can add your 2 cents.
Yeah, I think most of what I'm saying is going to be speculative too. But I think it's just a conversation and a collaboration because everyone is trying to come to terms with what are the capabilities of these new models and the technologies that's coming up. And I think it really depends on what is it that you're claiming to do. I don't think the FDA will be close to clearing something like a ChatGPT that has an infinite set of use cases. But if we can potentially narrow down the scope of the use cases, and at the end of the day, just be really data driven. Are you supporting the claims that whatever submission you're making is required to have? And I think it will be a collaborative process, but I'm hopeful for the future. But I think it will still be a very different process than what we've seen over the past few years or so.
So how do we go from here to there? I mean, if you look over here, I mean, we're still with the majority of the AI vendors are single task models, built in the traditional sense. And now you're talking about this wonderful potential, and and I think all of us now are experiencing some use cases where this is the way to go. So how do we go as an industry from the current state to a base model, not using a foundation model structure, but a base model based approach, a multitask model instead of a single task model? How do you see that evolving? Maybe Jason. Sorry, I'm not distributing it correctly, but you're going to hit it this one again.
So it's funny because that has been a question for several years now, right? I mean, the model that one model that sort of rules them all isn't a new thing. It's not a new concept, right? And I think from a base model standpoint, I mean, a lot of organizations are trying to move in that direction. I think as soon as we saw, probably prior, but I think you've seen it most as generative models started kind of like coming out, that they have many, many different, tasks that they can handle from a multimodality standpoint, as well as from a specialization standpoint. But getting to the question, I think, regulatory organizations have to adapt. It's something where you see in the industry that in many cases, the industry pushes things forward because of patient need. In most cases, I mean, the fact that, studies keep going up, turnaround times, need to be reduced, etc. It's a need. So, the industry, as with anything else that comes out, from a medical imaging standpoint or a general healthcare standpoint, regulatory has to adapt. And I think all of us here are pushing forward irrespective of, whether or not it exists now. So I think that it will come. I can't tell you deterministically when.
Actually, maybe you want to add to that too.
I think at the end of the day, showing compelling data is going to be what is needed, both from a clearance but also an adoption perspective. I think one of the challenges that we're seeing as a field right now is that there is a whole host of models that are cleared and can be commercialized, but then when a hospital tries to validate it on their own particular unique data sets, there's a differential in performance. So I feel like the more compelling the data set that we can provide for regulatory clearance, for potential adoption, I think the more trust and confidence we can build with our end users as a community. So just striving to compute the metrics that will drive adoption, success, and utility is something that we should really focus on as a field. Maybe we can come up with what those metrics are, and then always try to lead with our data. And hopefully that is something that can really push the whole field forward.
Yeah, I think data-driven insights are a critical component and a path forward. I think also data-driven from the perspective of how does your solution help to improve radiologist workflow? Does it speed things up? Does it save money? Does it mean that there are more studies that radiologists can read daily because we've found solutions that can bring at least some portion of automation to the process that really help to kind of grease the wheels and make sure that radiologists can get through a day without having to review 200 studies, that they can actually not be burnt out and focus more on the more complex studies than maybe the normal chest x-rays, for example. So I think that that optimization is really critical, and I think Akshay's point, measurement and being able to kind of show where the improvements lie and how you can move the needle are critical.
Yeah. I mean, maybe I'll add just a quick perspective on this and we can transition. I think the way we kind of see it is I think it brings the provider back into control. I think, right, the challenge with the current task-specific models is I think providers feel out of control because you get a model, it's supposed to be FDA cleared, it comes and it doesn't perform like it's supposed to perform. What do I do? And then you end up in a bake-off and none of them perform what I do. So then I'm stuck. So now I think what you have in this paradigm shift is I'm now bringing a model that might have been initially fine-tuned, right? But now I have the ability to fine-tune in my own environment. So I think we're evolving. I think this is what's probably going to trigger the transition is when institutions are capable of fine-tuning these models, in a regulatory context, on top of maybe what already is fine-tuned to get there. And I think, actually what you guys are doing, and I think RP's acquisition is a testament to what I think is happening there. Our lineage with RadNet is a very similar approach. So I do think that is probably going to be the shift. I don't know if we're there yet, but I think that's going to trigger some of the shift in the business as well, right? So maybe with that, I just maybe one quick thought, and I think it'd be interesting to open it up to questions. Maybe just around the room, one sentence on, how do you think this is going to evolve over the next 2 to 3 years, or comment on a little bit on what are we going to be able to do with these models in practice in the clinic in the next 2 years? Maybe we'll start with you, Akshay.
I think we'll still be doing the same things that we're doing right now, but more accurately and more efficiently and at a higher volume. Because I think the role of the radiologist is still pretty clear in terms of what the needs are. I think our models can just allow radiologists to practice at the top of their license.
So I think the consolidation of radiology toward teleradiology and other organizations is something that's being seen a lot. And that's for multiple reasons, right? One of the reasons, of course, is because it is hard to deploy software in healthcare, which includes AI models, and methods to, improve operations within organizations. I think that will continue, and I do think that in itself will allow organizations, radiologists in this specific case, to gain access to more modern, models, whatever the next generation of model will be, to provide more, operational throughput, for their daily life. I think that's going to be something that continues.
And I think that, flexibility and adaptability is going to be a critical component that I think folks don't have access to today. And I think that that's something that, foundation models in particular are supporting here, and that we're going to start to see people recognize more and more that you can provide feedback and iterate on these models and improve them regularly. And I think that fine-tuning approach is really going to, start to resonate with folks where today the solutions that are out there just don't offer that flexibility.
Great. Thank you. Maybe this is a good time to maybe transition to any questions out there. Anybody want to add any ringer questions? Brian or Melon? Yes.
What's the biggest challenge?
So Brian says, what's the biggest challenge?
I think post-training is a challenge, and in particularly around the annotation process. Working with radiologists, really understanding how complex this data is, how the chest X-ray, for example, is not ground truth is up for debate, which is always a challenge. And so, really getting the right clinicians to assist with that process and making sure that you have the best labeled data that you can use for that post-training process is one of the more painful parts of the process.
So 100% agree. Post-training. Technically, I think we see it all over the place that post-training is something that's extremely complicated. I also think just keeping radiologists up to speed with the sort of technology, as it kind of comes out. It's kind of known that radiologists who are just coming out of school are well adapted and well fitted for the market as it is today. But even those who are coming up with the technology are frankly having a hard time keeping up with the papers that are coming out when it comes to new model architectures and new ways to do things. So if the physicians themselves trust the technology, they'll use it and they will adopt it. So I think that's one of the hardest challenges.
For me, I think there's two challenges. One is it is really hard to build models that work 99% of the time, especially when you're going beyond these simple classification tasks. I think there's this perception that fine-tuning can sometimes be easy, but I think I'll take, for example, Google, right? Google has Gemini and Google has Gemma. Gemma is open source. People can fine-tune it. People use Gemini because it is the best performing model that's out there. It just solves your task because it is very challenging still to be able to take the best pre-training approaches, marry them with the best post-training, and just being able to build that end-to-end AI stack, I think is non-trivial. It still feels like a little bit of an art rather than a skill right now. So having people with those skill sets who are able to build, wanting to be in this community rather than increasing click-through, that's a challenge. And then the second challenge is really combining those people with your end users. How can you co-develop, really understand what are the specifics, the complications that you need to worry about? Having both of those align in the right place at the right time, I think is really hard.
Agreed. Any other questions?
Yeah, my question is, how would you actually compromise between the need to have a foundation model that can work on a variety of applications, but at the same time be able to customize or fine tune the model to be very good at certain downstream specific application.
Who wants to take that? So I think maybe if I can rephrase a little bit, I think task specific models versus a base model that can be adapted. How do you guys see the trade-off? Is that fair? Okay.
I'm happy to take a first stab. I really like thinking about models in terms of what is the task that they're performing. For me, it probably doesn't matter if I'm using one model to solve two tasks or if I'm using two models to solve those two tasks individually. Being able to define what is it that you're trying to solve, being able to define useful success metrics to know whether you've solved it or not. I feel like being able to come up with that definition and a paradigm that allows you to evaluate robustly, I think is a challenge. So I try not to think about it in the broader sense of multiple tasks. Pick your task, see if it works, and have quantitative metrics and data that you can extract to show that it's working or not.
Why not? My answer is very simple, cost. I think a large portion of whether you're going to train or leverage a pre-trained model or fine-tune a model, use a large model comes down to cost nowadays. Now, I mean, there are many cases in which people use multiple models for multiple tasks that could be related or not related. But my single answer at this point is cost.
And maybe I'll add a little bit. I think it's also where you're coming from. So if we look at, let's say a space that we're in right now, which is breast cancer detection, we have a pretty damn good breast cancer detection model that's tuned for that purpose, task specific. So do I really want to put a foundation model together to redo that? Or do I want to put that model together to find me this other support feature, fibroadenoma, find me landmarks, find me, etc. So then I can really start to blend both types into my endpoint, right? Now, the benefit is that's already approved. I don't have to go back and re-get that approved if I started with the foundation model. So I think we're going to be in a mixed world depending on where you're coming from, right? And that's how I see this universe, which is task specific, still staying alive while we supplement them with models that then provide other pieces, right? So detection with reporting tools, for example, right? And you might use both types of models to then read a breast cancer case, right? So maybe with that we can close since we've been chatting for a while. I want to thank the fellow panelists. It's been actually a lot of fun also to getting to know you guys a little bit here. I hope we can stay in touch as we go forward. And I want to thank the CARPL team for bringing us together, as they always do. So very much of a ecosystem strategy, which I really love about working with these guys. So thank you to the CARPL team, and look forward to doing this again maybe next year. And I think everything will change. So look forward to that. Thank you, guys.